Good morning, welcome everybody, welcome to OpenConf. We're going to talk about trust. Never trust a monkey. Let's see if I have a clicker. Here we go. The Chasm, the craft, and the chain of AI-assisted code. So, Landos and George did a very nice opening when they actually managed to vibe code a really working application, actually two of each, in 15 minutes. Who was impressed? I was impressed. Yeah, lots of people were impressed. Who were like, okay, now let's see how it does something that is actually software. Right. Games and stuff without backend, without APIs, just HTML and CSS is very nice, and it's a lot of fun. Does it tell us anything about how those models actually manage with a real computer science, a real software engineering, real tasks for day-to-day? I think that's a question that you might ask yourself, and we will try to answer. There is a lot of research that has been done in last years about the quality of AI software, and it's not great. 65%, 43, and 31, those are the percentage of correct code in different models. So it's about 50%. 50% of the time, models are on point, other times they are definitely not. What else? This is like very recent from August. It's a nice research done by the good folks at Sonar. So you probably heard about Sonar, Sonar Cube, and Sonar is basically providing you with tools to assess software quality. And this research found something very, very interesting. What they say is, you know how every new model comes with great benchmark marks, like how they are better than on the previous ones. What it was, Gemini 3, released 2 days ago. The fastest model ever, the best model ever, the best coding model ever, and what's not. Now, what the folks at Sonar found, that there is absolutely no correlation between the marks on those benchmarks and the software quality that the software of the generated software, which is a sad story, but maybe not very surprising. Another very interesting research, and that's from our friends at Kodo. This is kind of hallucination frequency versus confidence to ship AI-generated code. I mean, it's not surprising that whoever believes that there is high hallucinations also don't trust AI. What is interesting is the percentage. Let's do this experiment right now. How many of you think that in a real-world setting with the real-world like software engineering, AI models generate more, hallucinate more than 20%? Yeah, that's about 76.4%. How many of you also don't trust it? The same people, again, on point, 76.4%. Very cool, very cool. So where does it leave us? It leaves us here. AI-generated code can't be trusted. This is a Stack Overflow survey, and obviously people who are still on Stack Overflow are not the biggest fans of AI code for the obvious reasons, so that's a little bit biased. But still, you can see that more than 50% don't trust AI-generated code. Somewhere between someone distrust and highly distrust, more than a half. And that's obviously very disturbing, but also very non-surprising for any of us who tried this stuff on a real code basis. Another interesting metric, which might not be as telling as the authors of this paper think, is what's it's called churn code. Churn code is a code that will be thrown away in the next 2 months. after it was written. And you can see here almost a hockey stick of how AI-generated code is going into this category of will be thrown away in 2 months. Now, I think that the idea behind it was, oh, the code quality is terrible, but about this one, I'm not very sure. I also think that maybe thrown away code, AI-generated code that is a churn code, is not necessarily a bad idea. Maybe throwing away code every 2 months is actually a good thing to do. That's something for you to think about. Now, there is another very big issue with AI-generated code, and that's that it is dangerous. 40% of the generated code found to be vulnerable. 40%. That's a lot, and this is very, very scary. Again, the same paper from Sonar gives a little bit more details about what those vulnerabilities are. So you can see here stuff like hard-coded passwords, and hard-coded generates code without any security, like APIs without any security at all. API IRLO and other research shows that API is that code that has encoded credit card numbers, for example, and also APIs that don't have any input validation and authorization at all. And again, you can see the sharp rise with AI-generated code. Asking to fix it as reliable as you would expect, self-verify, generate correct code and send verify its correctness. So basically, AI is in charge of fixing its own bugs, and it's obviously cannot do any or bug fixes, but report that bugs are resolved. Well, yeah, inaccurate test reports, that's exactly that. It checks itself, it fixes the test instead of fixing the code, this kind of stuff. So yeah, my name is Baruch Sadogursky. I'm at Baruch on the internet's head of developer relations in a company called TaxCare. We do absolutely awesome t-shirts, as you can see. I have a lot of t-shirts to give, so we will try to interact during this talk, and whoever interacts will get a t-shirt. And generally, if you just come and talk to me, you will get a t-shirt for sure. Now, what we do in TaxCare on top of t-shirts is we provide security patches for end-of-life software. So if you are not very impressed with the quality of the newest software out there, and maybe think about, you know what, I'll see how it goes before I upgrade to the latest version, talk to me. We can help you thriving on older versions of open software faster without needing to upgrade. As Lena mentioned, Java Champion and wrote a couple of books. And the most important slide of this talk is this. If you go to shownotes.taxcare.com, you will find there a page dedicated for this talk with the slides already uploaded, the video that I am double-checking that I am recording right now, all the links for all the research that I mentioned and everything else that is going to come. Conveniently, it's in the bottom of every slide, so you don't really need to rush and try and access now. If you want to, there is a QR code which will go away in 5, 4, 3, 2, 1. Okay, couple of more. Okay, good. The good news are you don't need a QR code because it's right here, and the QR code will come back. So don't worry about it. Okay. So let's try to fix the problem, the exact problem that I showed you, and obviously you all agree that it exists. Let's go to the beginning of software. How software starts. Software starts with software design documentation, right? Or product design documentation, or product definition document, or software definition document. There are a lot of names for this document. And as you know for sure, this document is write once, someone wrote it in what we call an ivory tower, decided what this product should do, and then read maybe once. We assume that the developers actually read it before they're writing software, but you know, maybe. Never updated, obviously. And the question is why? Why there is such a huge disconnect between what business and product want us to do and what we ended up doing. And one of the reasons is that we think that we speak the same language, which is not necessarily true. Which is not necessarily true. There is a couple of issues. First of all, English is just ambiguous. There are a lot of meanings for the same words, and expressing technical nuances in English is hard. There is also something that is called as the curse of knowledge. Curse of knowledge is a psychology phenomenon, speaking about coding fast and slow, and Dr. Kahneman and what's not, I'm sure Lena, as an educator, can agree with me on this one. So basically, what's going on is you come to a course in your university or college or what's not, and the teacher goes like, welcome, we will start from the beginning, and you kind of, get distracted for a second, and then you are like, back, and this is what it is on the board. And you're like, how did we get there? The problem is that the lecturer or the teacher knows the material that they try to convey to you. And what we already know seem trivial to us, seem very familiar and very simple to understand. And once it's conceived very simple to understand to us, we expect all you to understand it very, very simply as well. So we don't explain it enough, we don't explain it deep enough to convey all the needed information. And it's absolutely the same in those software definition documents, right? The product people, the business people, they have this picture of what the software should be in their head. And only part of it gets explained in those documents. So, human misunderstanding with the curse of knowledge is one of the reasons why software definition documents don't work. What else? Context is not shared. This is part of that as well. So the business people and the product people that talk to the customers, they have a vision of what the customers really want. Do they manage to express this vision in those documents? Well, not always, and more frequently they don't than they do. Responsibility boundaries. If something is not clear, will the developer go out of their way to get the explanations? Maybe yes, but probably not. They will just do what they understand was implied, not necessarily clarifying everything that it needs to be to clarify. And it creates a kind of animosity, kind of a friction between those two. This is a very old picture from like 15 years ago when there was a perceived friction between developers and testers. I don't know if you remember those times. Who thinks that this picture is actually true? Not a lot of hands, and I agree with you. I think this is bullshit, and in the end of the day, the QA people and the testers are on the developer side. We want to write better quality software. They help us with that. Thank you very much. You're great. Then it was that. It was the whole silo, throwing software over the fence, checking, like clocking out at 5 p.m. and leaving the ops people deploying our crap into the night and then being on call and what's not. This is also has been solved. How? How this is solved? DevOps, thank you, of course. Yeah, DevOps. DevOps solves it perfectly. I'm not saying that the industry is past that, but we know the solution, right? Doing proper DevOps actually solved that. We might do it, we might not, but it has been solved. But this is very real. And that's exactly what we're talking about, right? There is this animosity because they try to explain something, we don't understand, they blame us for not understanding, we blame them for not explaining stuff, and there is a lot going on here. So the trust problem that I started with, apparently it's not only with AI, it's between humans too. And next thing we know, that's my favorite Venn diagram. Right? This is something almost all of us can relate. No? What? Postgres, yeah, there is one exception, and that's definitely Postgres. Yes, that's a t-shirt. Postgres is a software that even people that know very well like. No one knows how it came to be that way, but everything else is pretty much here. Okay, but you know what? Sometimes it does work, and Postgres is a great example. Why does it work despite everything that I have we spoke about? First of all, is good intentions. In the end of the day, we all want to create good software. Business people, product people, software engineers, QA, ops, security, everybody. And we make a decent effort to make this happen. We take pride of our work. Definitely, like mastery is one of the pillars that drive us forward. And this again helps us solving the problems that arise and asking the right question, getting the right answers. Tests and QA help to an extent, obviously, but in the end of the day, the discipline that we put into covering our code with tests and then doing external QA really helps. And end result observation, right? We have something that we wrote, we run it, we look at it, we see if it works, if it doesn't work, we do all that. And context might be different, but still pretty much the same. We are, in the end of the day, in the same industry, with the product people, with the business people. In the end of the day, we do speak the same language, despite misunderstanding that arise somehow. Now, generative AI changed the game. Every point here is now out of the window. Generative AI doesn't have any intentions. It doesn't have any special software engineering professionalism. Tests and QA, you saw it. It's a self-verifying game when it creates the test for the bugs that it wrote so the test will pass. There is no end result observation. It just generates code, and it won't even try to run it. It will just say, well, I think it works. And obviously, there is no common context because there is no context for LLM. LLM is a stateless service that doesn't have any of guessing words that doesn't have any context at all. We can provide it with context, but not a lot, as you probably know. So, whatever good parts of software engineering that we had are now completely gone, with all the bad parts of software engineering, of misunderstanding, misalignment, is still there. So, not surprising that 76.4% of you don't trust AI-generated code. And it creates what I call the intent-to-prompt chasm. So we have a user, and then we have the stateless LLM service, as I mentioned, and we ask a question. How do we use Spring Boot? And the answer will be, cannot really boot a season of the year because there is no context. There is no professionalism. There is not understanding of the nuances that might have or might not have there. On top of that, LLMs are by definition stochastic systems, which means they are not deterministic. We enter the same prompt, and we will, by design, get slightly different results. And this is exactly how it should be, because otherwise LLM just won't work. The idea is that LLM finds similar concepts. There is this slider that's called the temperature that we can control how similar concepts we want. So if we ask, what is like a king, we can get results. The queen is like a king, which is one setting on one temperature, but also a human is like a king in a much more relaxed temperature. There are similarities, but if we want a better answer, we need to adjust the temperature so it will give us similar answer. If we crank the temperature too much, it just won't work. The only similar thing to king with a temperature 1 is king, which makes it absolutely useless. Once we take the temperature down a bit, we start to see variations. We want those variations. But those variations means that LLM are not deterministic systems by default. It's great for conversations, and this is why everybody are in love with conversationalist LLMs, but it's obviously very bad for code, because for code, we want to have correct and deterministic answers every time. And this is just not how it works. So what we actually do have is something like the infinite monkeys theorem that goes like, if you give an infinite number of monkeys an infinite number of typewriters, after an infinite time, they will produce works of Shakespeare. LLMs are exactly the same. We gave them GPUs instead of typewriters, and they are slightly better skewed towards providing what we want than just random. But in the end of the day, when we ask them for Shakespeare, sometimes we will get Shakespeare, but most of the times we will get something Shakespeare-ish, something like Shakespeare, but not quite. And this not quite will also be different every time, which is a terrible idea for generating code, because we want correct code every time. So, what can possibly go wrong? And then you say, you know what? But we have code reviews. Code reviews are a very good place for professional software engineers like us to step in and see where it's Shakespeare-ish and tweak it so it will be Shakespeare. Isn't it a great idea? Well, not really. Code reviews have what I call the looks good to me syndrome. And this is where most of the code reviews end up with looks good to me comment, regardless of the actual quality of the code in the code review. Why is that? Because we're busy with other stuff. If you remember my talk from 2 years ago, we spoke a lot about how context switching is terrible. Code reviews are unnecessary for us, well, being necessary for a company or the industry, but for us personally, unnecessary context switch. We need to put away what we are doing now and look at someone else's code. And you know what we developers hate? Reading other people's code, including our code from 6 months ago. Now, we really, really don't like it. And we obviously won't like reading any AI-generated code. The result is, looks good to me, on our colleagues' code, and definitely on AI-generated code. No one has time for reading AI-generated code. So I think we can all agree that the more AI-generated code out there, the more terrible software quality is. And we should do something about it. We should do something about the distrust that exists between us and the code that AI generates. And it's not our fault, it's just because the code is bad. How can we improve it? Now, what I want to present you is the idea of verifiable intent. The idea that we're going to unravel now is how can we make sure that the intent that we have on our hand, us, product managers, business people, is verifiably expressed in the code that is generated. What if we code in the intent and always verify against it? That's what we will try to do. And I call this intent integrity chain. There is a hashtag for intent integrity chain right here. So if you want to discuss it on your socials, please use it. And what we want to do is find a way to ensure the code does exactly what it has to do. We start with guardrails for monkeys. And tests are guardrails for us, the developers, has been always. It can also be for monkeys as well. We write the tests first, and then we let the monkeys type on their typewriters until the test passes. Once the test passes, we know for sure that the intent that we expressed in the test are captured correctly. Looks familiar to anyone? What is this? TDD, of course, it's exactly TDD. And TDD sounds like a great idea. The only question is, who's gonna write the tests? Who's gonna write the test? Us, the developers. But who has the intent? Business people and product people. They are the ones who came up with the software definition. So, are they gonna write the tests? They're not going to write the tests. Definitely not. So, we actually still have the chasm. Yes, there are software definition documents out there written by product and business people, and then developers write the tests, and then LLM generate code to the spec. The chasm is still there. There are those software definition documents, and there are the tests that we have written. And on top of that, developers really, okay, maybe I'm wrong. Who practices TDD? 4 hands out of a full room. Yeah, developers hate TDD. Developers hate TDD for a very obvious reasons, which also to do with psychology. We are biased for action. We are in this business, in this industry, because of a dopamine provided to us by writing code and seeing it work. When we think about a problem, we think about how we're going to implement it in code, and then we want to do it immediately and see the results. What we don't want to think about is, okay, how going to test it? Okay, what are the exceptions? What are the corner cases? We have to think about it, but first, we need the dopamine to keep going. We want to code the happy path first, see it working, and then start dealing with tests and everything else. We already know how to solve the problem, so we want to go and solve the problem. Now, here is how can we avoid it? What if the test wouldn't look like test? It would look like English, like code. How about we write spec first, and it looks like English or Greek or any human language for this regard, and the product and business people can read and write those specs. I mean, that would be nice. Instead of writing those unstructured documents that then we need to understand, they actually go ahead and write the specs, and we're all from there. And someone already said the right words. What is this? Yeah, BDD, absolutely, of course. That's behavior-driven development. It's been with us for at least 15 years, and it is probably as popular as TDD. Who does BDD? Yeah, even less. All right. One of the problems why BDD didn't really pick up is, you see, right? We try to ask product and business people to write spec. Are they going to write the spec? No. They're not going to. So, true story. I once asked a product manager to actually write a Gherkin spec. And Gherkin spec is, you know, it's like the spec which is structured like given when then, basically. Now, obviously, they have the knowledge. And obviously, they can write it because it's not code, it's just structured text. And what they told me is, so Baruch, you're a developer, right? And I'm like, yes. And you take pride of the code that you write. And I'm like, yes. And they were like, so I take pride of the documents that I write. I want them in the exact format that I think express my intent perfectly. I'm not going to compromise writing your bullshit. I'm going to create my wonderful documents. So the chasm is still there. There is still software definition documents, and there is the chasm. And then developers end up writing those specs, and then tests are generated, and the LLM generates the code. And we are back to the question, why are we bothering? If we don't want to write tests, which are code and kind of fun, definitely we're not going to write specs, which are not code and not fun. Maybe we can use LLMs here. How about we have the software definition documents, which we feed as a prompt to our LLMs. And then we let LLMs create the specs from those software definition documents. And then everybody can read the specs, including the product people and the business people. They didn't have to write it, they only need to read it, which is a reasonable ask. And then, obviously, LLM can generate the test from those specs, and then LLM can generate the code until the tests are specified. That looks not bad, right? It looks like we achieved what we wanted. It looks like we captured the intent here, and then we have the entire chain that actually guarantees that the code that we have here captures the intent that we had on the other side. Well, yes, but actually no. And the problem is monkeys. You remember what's going on with monkeys? They are not deterministic. And we let the monkeys be trying to build this trust in a lot of steps. And if I want you to remember one phrase from this talk is, never trust a monkey. Once we let the monkeys into the process and we don't verify after them, we will get non-deterministic, non-trustworthy results. And we do have a lot of monkey business here in our process. So the prompt is created by humans. So that's okay. But now the spec is generated by monkeys. That means that we cannot be sure that the spec is exactly what it was in the prompt. And then the tests are generated by monkeys from the spec. We cannot be sure that the tests are exactly what we had in the spec, which by already we cannot be sure that it was what it was in the prompt. And then the code is written with the access to the test by monkeys. Remember the circular verification? When monkeys adjust the test so it will be green although they didn't fix the bugs? That's exactly that. We have a lot of issues with monkeys here. So did we do anything really? Did we improve our trust in any way? Not really. So let's see how we can solve it. The idea is that we won't let monkeys do what they shouldn't touch. So we will replace the monkeys with the algorithms where possible. So those are the 3 steps that we have the problem with. Spec generation, test generation, and etc. So let's fix the first step, the test generation. Let's fix this monkey. So the way we solve the problem here is we kick the monkeys off, replacing them by robots, replacing them by deterministic algorithms. Now, spec is structured. And Gherkin is one example that you might be familiar with from a tool called Cucumber. And what Cucumber does and did for the last, 20 years is exactly that. It's converting algorithmically, repeatably, predictably the spec to tests. So if it already does that, we actually don't need the monkeys. We can replace the monkeys here with an algorithm, and then this particular point is solved. We can trust the tests generated from the spec because no monkeys involved. What else can we do, right? So we can prevent the monkeys from messing with test validation. The reason, right here, right, the generated code we cannot trust because it has access to test. The way we do it is we won't let it access the tests. How we won't let it access the tests, mess with the tests? We make the tests read-only. We can actually change the files to be read-only during this step. Or we can put them in a Docker container, which will be read-only. Or there are a bunch of other stuff we can do. But eventually, all we need to do is log the tests. And once we log the tests, we can also we solve this problem too. Now, there are 2 more steps which cannot be trusted. Well, actually 1. And that's the spec generation. How can we make sure that the specs are exactly what the intent was? And here I have a completely out of the blue Ronald Reagan and Mikhail Gorbachev. And the year is 1988, and the place is Reykjavik, Iceland. There is, they talk about nuclear disarmament between USSR and the United States, and Gorbachev like, sure, we are going to like dismantle all of the nukes. And then Reagan goes, doверяй, но проверяй, in the perfect Russian, which stands for trust but verify. And this is exactly, well, he didn't trust Soviet Union much, which makes sense, and we shouldn't trust LLMs much, which also makes sense. It means that whatever is generated by monkey should be verified. And the way we verify it is our own eyes. We just read through it. It's true from prompt, it's created by people and verified by other people, and it's true from spec. Yes, it's generated by monkeys, but we can read through it, all of us, developers, business people, product people, we read through the spec, it reads like English, and we say, well, yes, this captured our intent, or no, monkey business, this is not what we meant. And then it might be because monkeys just did monkey things, or because we actually had a curse of knowledge. We didn't express our prompt well enough, and monkeys understood what monkeys understood. So we need to go back to the prompt, to our software definition documents, and fix them to express our intent better. And down from there, no monkeys involved. The test is verified, and the code is verified even if we don't want to read it. It's still okay because we replaced this verification with algorithmic decisions and file permissions and this kind of stuff, so we don't have this problem. In the end of the day, now we have the intent integrity chain as it should be, verified. So software definition documents are prompt, LLM create the specs, and here is the human verification of intent is captured correctly in the specs. And then algorithms generate the tests. We don't have any problem with trust with repeatable and reproducible algorithm. And then LLM implements the tests, but the tests are real only, so they cannot mess with the tests. In the end of the day, we'll have exactly what we ask. So this is our intent integrity chain. And it works because everybody writes text. The developer, the business people, the product people, and they're fine with writing text. Specs are reviewed by all, so there is no problem there. Software definition documents and specs are now living documentation. We cannot generate new code without adjusting those. They will also be up to date. And everything else is derived by the specs. All code is verified by machines. No one has to read code, not in the code reviews and not any time else. And this makes our lives much easier. So intent integrity chain is what behavioral-driven development was meant to be. We define and agree on intent between all the humans, and then we verify everything that the AI does, either through human observation or machine verifiable way. We don't trust AI for what we cannot verify, and Gherkin specs and are definitely working now. Now you may ask, are they good enough? Can we express all the nuances of software design, architecture, and implementation in Gherkin specs? Maybe yes, maybe not. We can actually do much more that you might expect. Security constraints, stuff like non-functional behavior, all that can still be expressed in Gherkin. Proven, and it works, and there are a lot of people who practice business-driven development, even here in the room. You can ask them how they manage with Gherkin. They will tell you that it mostly does the job. But sometimes there are constraints that are hard to describe. And people who deal with LLMs now understand that this is a shortcoming. And better speccing tools emerge right now. This is the hottest topic in AI conversations for software development. I just came yesterday from a conference dedicated to exactly that. AI Native Con in New York was all about spec-driven AI development. And we spoke there about tools like GitHub Spec Kit, which is super popular and gets a lot of interest right now. Kiro was released 3 days ago by Amazon. It's an agentic IDE, which is 100% about spec-driven development. And there is a company called Tessel who does exactly that. You make the spec, AI codes and maintains. That's exactly what we are talking about. They pivoted recently to what it's called spec registry, which is actually a living documentation that AI can use for open source software out there, but it's still very, very related. So, as Andre Campati said, 3 years ago by now, the hottest new programming language is English, and this is very true. With Intent Integrity Chain, we start with English, and that's all. Everything else derives from what we say to each other. So Intent Integrity Chain generates consensus. Features are verifiable back to the requirements. We can start trusting AI code, but there is some work to be done in the specking space. So with that, thank you very much. I'm at J. Baruch everywhere on the internet. Thank you. Talk to me about TaxCare. Get a T-shirt. This is OpenConf. I think I got the hashtag right. Intent Integrity Chain. Show notes to taxcare.com. The video, the links, raffle for thank you for coming here. Everything is there. That's the QR code. Thank you.
Thank you.
Thank you. I will steal the GTM syndrome. I really like this. So let's see if we have questions. I think we have one.
Yes.
But
should we wait to be displayed, or do you have it already?
no, I don't have it. So
Okay.
What do we need to do with that?
Waiting then? No, it's okay.
Okay.
They will fix it.
Yep, okay. Questions, yes. How do we do questions? Is there a mic? No, they would just shout. What do we do with questions? There is the questions in the
there should be already a question submitted. Yeah, let's see about this.
What would be one advice you would give to a software engineering looking for their first job in this year? That's a great question. So the good news are, as you saw, mastery is not going away. Understanding software is now more important than ever. Because of a new level of abstraction, now we write our code in English. Understanding what is going down from there is very, very important and will be proven to be more important in a very near future. We now have a storm of a very bad software coming at us from all the directions because of AI-generated code that is generated right now before all the validation kicked in, and someone will have to clean it up. And the next generation of software developers will be the ones who will fix what is being broken right now. And the way to fix it is understand how software development works. So you might say, you know what? Software developers are not needed anymore, and no one cares how the software is written because everything in English. But in the end of the day, if you know how to drive the car, it doesn't make you a mechanic. And mechanics are a very, very good profession to have, especially when most of the people don't understand how the car works. And this is exactly where software engineering is right now. We're switching from a lot of mechanics to a lot of drivers who write English but don't understand how it works. The better you understand how it works, the more money you're going to make in the next 15 years.
Okay, thank you.
Thank you.
Any other questions? No? One question?
I have one.
Yeah, go for it.
Do you think all those tools are going to help more skillful engineers or less skillful engineers? Or will make less skillful engineers worse? What do you think?
So that's a very good question. Yes. So as with every new level of abstraction, it helps separate good professionals from not so good professionals. We have there as well. And in the end of the day, as more people become drivers and less people stay mechanics, the real good mechanics will thrive. The less good mechanics will probably won't find their place in this new world. So the real way to excel is to be good at what you do. And in the end of the day, you know what, if that's not for you, and you know what I hear a lot is, hey, I want to write code. But intent integrity chain is all about how I don't write code, so I don't like it. I still want to write code. You know what? There are people who messes with their car as a hobby. And if you are not happy with not being able to write a lot of production code, you can still write a lot of code. And if you can maybe do something outside of your work, that it will be absolutely amazing because how good you are, it will become your new work instead of doing something else. So I think mastery is still very, very relevant, and we now will see a lot of separation between good professionals and not so good professionals, as it came over and over again in every abstraction leap that we live through, starting from compilers versus assembly, and then object-oriented versus procedural, and then cloud versus on-prem, and then DevOps versus what is called sysadmins, and it's all the same.
Yeah, and I like the analogy of mechanics and folks that messing with their motorbikes or their cars as a hobby. Yeah, that's a good analogy. I will use it.
Yeah, absolutely.
Actually, yeah.
Go for it.
Yeah.
Maybe
Let's do the last one. Yeah.
Yeah. What's my favorite idea? I guess despite the rise of the new agentic IDEs, like Cursor, Windsurf, Kiro, you name them, my favorite is still IntelliJ by JetBrains, just because it gives me more understanding of the code. It gives me a lot of tools to understand, debug, etc., etc. And this is tinkering with the motor that we spoke about. I might not need it for my production code, but I definitely enjoy understanding what's going on. From the agentic IDEs, Kiro is by far the most interesting one because, as you might notice, I'm very into spec-driven development right now, and Kiro is exactly that. It's not full intent integrity chain, but it's going to the same direction. I love it. It is generally available since 3 days ago. Take a look at it, give it a try.
Thanks.
Thank you.
Thank you.
Thank you, Baruch.